So let's see together how the alpha-beta algorithm is working. So actually we start with the initial node having alpha to minus infinity and beta to plus infinity. And we're calculating now, trying to update alpha by calculating the alpha-beta value of the successor here. We send minus infinite plus infinite to it. We update the beta value with 0 coming from here, and then we check if we have to update it. No, because 15 is greater than 0 and 5 is greater than 0. And actually we do not do a cut because beta did not become less than or equal to alpha. We update here the value of alpha because the maximum of minus infinity is 0 is equal to 0, and then we continue here. After this step, actually, we send the new value of alpha with plus infinity for beta to the successor, which actually forward the value 0 also plus infinity to the successor age, having the minimum of -1 and infinity is equal to -1, then the beta value will be updated to -1. At this moment, we find out that -1 is less than or equal to 0, which means that beta is less than or equal to alpha, and this makes it actually a case where we have to make a cut on the remaining part of the tree, since beta, which is equal to -1, is less than alpha, which is equal to 0. And now we propagate -1 to the father, but the value of this node remains 0 because it's the maximum of 0 and -1 is equal to 0. We do the same thing with the last node, and we find out that at the second step we have to do a cut, since we found a -2 and a -2 is less than the original alpha value, which is 0, and then at that moment we have to do a cut on the very last node. When we propagate the -2, we do not update the value of alpha because alpha should become equal to the maximum between the previous alpha, which is 0, and the new alpha beta value, which is -2. The maximum is 0, and we remain with that specific value. And this is why we could do two cuts, but nevertheless find out that the path to follow is the path going through B, and the action to be executed will be that one.